Chapter 5, Section 6 is about inverse variation. So by the end of this lesson, you should be able to solve inverse variation problems, and you should be able to compare direct variation, which we just learned, with inverse variation. Here's another activity. Suppose you are part of a volunteer crew constructing affordable housing. Building a house requires a total of 160 work days. For example, a crew of 20 people can complete a house in 8 days. How long should it take a crew of 40 people? Copy and complete the table, graph it, and then describe what happens. So right now I want you to pause the video, figure out the rest of the table, and make a graph over here on the side. So hopefully you figured out that if it takes 20 people 8 days, if you double the amount of people, it's going to cut the number of days in half. So it should only take them 4 days. So then you should have came up with a pattern here. Some of these were a little harder to find than others, but this one you should have known, and then this one we just figured out. And then hopefully you can figure out the rest, because each one of these are going to multiply to make the 160. 40 times 4 gives you 160. 20 times 8 gives you 160. 10 times 16, on and on and on. If you multiply these together, you end up with 160. So when you graph it, you get this weird shaped thing that started off really high, and then it dropped down, and it kind of curved around. And if we could have fit more on there, the curve would have gotten even smaller. So describe what happens to the construction time as the crew size increases. Well, as that increases, like this did here, the construction days decrease. They get smaller and smaller. So the more people we have, the less days it's going to take. So we just found something that had an inverse variation. And an inverse variation, it looks like x times y equals k, or you can write it like this, y equals k divided by x. So remember, direct variation was y equals k times x. Inverse variation is y equals k divided by x. That's how I remember it. And then also you can multiply it to get this one if you multiply by x on both sides. That's where they get that from. So the constant of variation is still this k that we talked about, but now it's the product of x times y for each of them. So if you go back here, when we multiplied each of these together, we got the same thing every time. But remember, with direct variation, it was the quotient or the division. So inverse variations have graphs with the same general shape. They're all going to look like that curvy thing that we drew. You can see from the graph on the right how the constant of variation affects each graph. So if you look here, the smaller the constant of variation, this one's only 2, it's really close to 0. And the bigger this gets, the more flattened out it gets. So if you know the values of x and y for one point, you can use that point to find the rest of them. So it says, suppose y varies inversely with x. When you see that, you should be thinking y equals k divided by x. That should pop into your head. They tell you 2 pieces of information. Y is 9 and x is 2. So write an equation. So this is just like what we did with the direct variation. I'm going to plug in what I know. So instead of writing y, I'm going to put in 9. And instead of writing x, I'm going to plug in 2. And then we can solve for k. So the opposite of dividing by 2 is multiplying. So I end up with k has to be 18. Now my inverse variation equation will say y equals 18 divided by x. And I can find as many points as they give me once I come up with the equation. Each pair of points on a graph is of an inverse variation. Find the missing value. So what we're going to do for this is figure out what our y is in this case and what our x is for this one. These have to be equal. Remember back here, we know that our equation is y equals k over x. So we can use that to find k for whatever point we know all of the information about. So I know that when y is 9, x has to be 5. Be a 5. And if I solve for k, just like we just did on the last one, I get that k has to be 45. So now I know that my equation is y equals 45 divided by x. And I can plug in what I know for my second point and find what I don't know. So I know x, so I'm going to plug that in. Y equals the 45 divided by my x, which is 3. And if you solve this, we end up with y is 15. So that means that this y here, or this point, has to be at 3, 15 in order for this to be inverse variation. The other thing that's kind of a shortcut is, because it's inverse variation back here, remember that x and y multiplied together give you your constant of variation. So if I take my x and my y here and multiply them together, they have to equal my x and my y here. So 3y has to equal 45, and if you divide both sides by 3, you still get 15. So let's try the next one that way. Remember, because we said that these are inverse variation graphs, we know that the k has to be the same. So if I multiply the first x and the first y together, it should equal my second x times my second y, because they're both going to equal this k. And then you solve. 75 times 0.2 is 15. And 3 times x we can just write as 3x. And if we divide both sides by 3, we get that x is 5. So now we're going to compare direct and inverse variation. Remember, direct variation is really a line. It's technically y equals mx plus b, but we write it y equals kx because the b is 0. And instead of using m, we use k for constant of variation. You will see this written as y varies directly with x, y is directly proportional to x, or this ratio is the same. And this ratio goes back to slope. I know we haven't talked about slope in this class, but remember, slope is the change in y divided by the change in x. That's what we're finding here. We're finding y divided by x. Inverse variation, the equation looks like y equals k divided by x. You will see it written as y varies inversely with x, y is inversely proportional to x, or the product of x, y is the same. So you'll have problems like this, where it just says determine whether the data in each table represent a direct variation or an inverse variation, and then write an equation. So we're looking for two things. We need to check if x times y equals the same thing. If that's the case, it is inverse, that we just talked about. Or we need to check that y divided by x is the same, and in that case, it's direct variation. So if we take a look at each one of these, let's try direct variation first. 12 divided by 3 gives me 4. 6 divided by 6 gives me 1. And 4 divided by 9 gives me 0.4, repeating forever and ever. So because these are not the same, that is not direct variation. So now let's check inverse variation. Multiply them together. 3 times 12 gives me 36. 6 times 6 gives me 36. And 9 times 4 gives me 36. So this being all the same means that it's inverse variation. So what we just found here, this 36, is our k. And then you have to remember that inverse variation looks like y equals k over x. So the k we just found was 36. So our equation is y equals 36 divided by x. Let's try the same thing with the other one. So the first thing I'm going to do is find quotient. 12 divided by 3 is 4. 20 divided by 5 is 4. And 32 divided by 8 is 4. So because all of these are the same, that means that this is direct variation. And what we just found right here, this 4 is our k. And remember, direct variation looks like y equals k times x. So instead of the k here, we have 4. So a lot to remember, but you basically just have to commit this to memory. So explain whether each situation represents a direct variation or an inverse variation. So we're looking to see if things are getting bigger as we multiply them together or if they're getting smaller as we divide them. So you're at a discount store. All sweaters are on sale for $15 each. So for this one, every sweater is $15 per sweater. So this is a constant ratio, and whenever you have a constant ratio, that means that it is direct variation. For the next one, it says you walk 5 miles each day. Your speed and time vary from day to day. So remember that distance equals speed times time. Our distance is staying the same, 5 miles, but these two things, S and T, are changing. So that means if you increase your speed, your time is going to decrease. Or if you decrease your speed, your time is going to increase. So if you take a look at those arrows, they show opposites. That means that this is inverse variation. So the sweater one, you have the same ratio. Every sweater is $15. The next one, you're still getting 5 miles, you're just getting it different ways. So I want you guys to try this physics problem with a seesaw, and then try this carpooling one where you're telling me if it's direct or inverse variation. Make sure you write down any questions you have, and we can go over them tomorrow in class. Have a good night.